to work with. On one hand, you need to work with these elements that represent your program, and you need to work with these elements that allows you to execute your program. Okay. And on the following pages, you have several details on the way the execution stack works, on the way that the execution stack works, symbol table works, and the output list works. And here you have the rules for the execution of the statement. Now you can see, you will see shortly, and we'll try to sketch a small class diagram, that you have several types of statements, and here is presented the compound statement and the assign statement. And in the first part, you can see that you have here you can see you have the stack or the program state before executing a compound statement, and then the second group is the program state after executing the statement. In this case, a compound statement is a statement that is built out of several statements, and executing this compound statement means just splitting or placing on the top of the execution stack the first part of this compound statement, and in the following just having the other statements that the compound statement had, in this case statement 2. And
I have a question.
Yes.
In this representation of the stack that we have on the whiteboard, I guess the top of the stack is statement 1, right?
Yes, yes.
So here, the top is on the left.
Yes, here it says, let's see here, that the execution stack for this example has S1, S2, S3, and S1 is on the top of that. Yes, yes, this is true. Okay, and let's go a little bit further. We have another type of statement. We have the assign statement, where we need to let's say we need to update the for ID, for a variable ID that is included already in the sim table. We need to update its value to the value val1. That is the value obtained by assessing that expression x. Okay, and this is the let's say the meaning of assign statement. Then we have this is let's say it seems to be a complex operation, this one of assigning a value to a statement, to a variable. But here we have several steps that that needs to be performed. You will see later when when we'll talk about types and values and expressions. We have the declaration of some variable as a statement, and this, sorry. Okay, so we have here. Here we have the case where we declare a variable, and this means we just add to the sim table this new ID. Okay, and in this case, if the variable is already declared, we should throw an exception. Otherwise, we should add a new entry to our sim table, which is a map, a dictionary, and for the key with the name ID, we just place the default value. Okay, Next, we have the print statement, that just simply assess this expression and adds to the output list, just adds that new value that is obtained. And then we have the if statement that allows us to assess this expression here, the condition of if statement, and according to that expression, that condition that is met or not, we place to the execution stack statement 1 or statement 2. So this is the execution rule for this if statement. We don't need actually to perform many steps here. We don't need to assess this expression and then to execute statement 1 if the condition is true. We just need to place statement 1 on the top of the execution stack, and then on a further step we need to execute this statement. So please try to imagine how this interpreter works. Okay, because at some point when we'll add another type of statement like while statement, we need, or for statement, we need to think about that as well. So at each execution step, we need to perform a simple step. And in this case, it would mean to assess this expression and add statement 1 or a statement 2 according to the assessment of this expression. Okay. So you can see here that execution stack is changed by statement 1 or statement 2. No peg execution means that nothing is added to the stack. So this statement is just popped out from the execution stack, and other statements other statement will be on the top of the stack, and at the termination of the program, it means that we have no more statements in our execution stack. Okay? Do you have any questions until this point? Okay, the next part of the file addresses the expressions that you may work with until this point with your interpreter, and you may have expressions that refer to numbers. Okay. Let's say integer numbers and Boolean values. And then you have another type of expression. Let's see here, arithmetic expression or a variable expression that allows you just to look into the sim table and take the value that corresponds to some entry, to some ID. And this is used many times in arithmetic expressions as well. Here you have the arithmetic expression where you need to add those operators. Division, here you need to handle division by 0, multiplication, and so on. And you have as well logical operator included in logical expressions. Okay, so here you have this operator and you need to have or at some point, and the same for or. So or is not described here, but for operator or is the same assessment rule. for some logical expression. So it seems to be a large amount of information. Let's discuss further how your application architecture should look like. Okay, so you need to use this architecture model view controller, and you need to organize your classes within several layers. So let's see what the layers should be. Let me check my my whiteboard because I'm not sure if it works fine. Okay, so let's see. So here we have the model that will consist of several packages that will try to include statements, and you will see that here are discussed. So those items that are included in this item 2 will correspond to some packages that you will need to include on the model or domain layer in your application. We need to work with types. We need to work with values, and other packages would be related to, let's see further. So here, let's discuss these elements in order. Here you have this interface I statement, that is an interface that consists of this execute method. That of course is an abstract method, is just declared within this interface, and from this interface we need to implement many other classes. Other important class for us is compound statement. Let's say it here, compound statement, which is a class, not an interface. Here is a sign or a representation of that relationship between interfaces and classes. Have you discussed it during the lecture?
Yeah.
Or have you do you recall it from the last year? Because we have another representation with the dotted line, or this continuous line with circle at the end. And here we have an interface in both cases, and here we have a class. So this is so these two representation are or these two relationship representation mean the same thing. Okay, so let's continue. Here we have an interface I statement that is implemented in this class compound statement, but here we have another relationship. Here we have relationships that allows us to see that within our class compound statement we have two statements of this generic type, let's say, or general type I statement, and here the multiplicity is 2 because here we have two attributes of type I statement. Okay, and here we have other types like print statement, let's see it here, assign statement, and all of them work with expressions, okay, or other classes. Just compound statement is more particular statement, and if statement as well, because here you can see it consists of two attributes of type I statement. And here we have the variable declaration statement as well. So here we can add other classes within our class variable declaration statement, sorry. So here we can add print statement, We can add assign, statement, and so on. Okay, all those classes are implemented from iStatement. And for if statement, we have again this relationship with iStatement, because within if statement we have those branches for and else statements. Okay, so here what I would like to talk about is what you should see your architecture. So you need to have a sub package within your model package that will consist of those classes that implement this interface iStatement. Okay, at some point you can see that you have this program state class, and we'll talk about that in a minute. Now, other element that is in your model package is represented by the type. So here is another element, is another package that you should include. Here we have another interface type that is the base type for integer type and Boolean type. And later, during other assignments, you add other types like string type, if I correctly recall, int type, and here you have again bool type. Okay, and here you can add other types at your choice. So here you have another sub package that works with types in your toy language. Then we have this interface value and specific classes, int value and bool value for the Boolean type. Okay, and here we have again this interface value, and here we can present another representation like int value, int value, and again bool value. Okay, let's go a little bit further and see what other element is included in our interpreter. We see that we have an expression interface, exp, that will be the base type for arithmetic expression. And here you can see that within this exp interface, you have this method declare eval, and you can see its signature. You can see that you take some item from the dictionary, from the, let's say, from the sim table, and you can work with that. And here is the implementation suggested for the arithmetic expression, and you will see that you have logical expression as well. You have variable expression as well, and so on. So you have here variable expression, logical expression, and let's see what else do we have here. You have value expression as well. Okay, so you need to add all the classes that are included. This is another package that represents a sub-package within your model layer. Okay, then you need to work with all those data structures that that are used for your that are used by your interpreter in order to run your program. And this is another package in the model layer, and here it is discussed the way that the execution stack is implemented, the symbol table is implemented, and the output part of your interpreter action. Okay, so for the stack, you need to work with a generic type. I think during this week you will talk about generics in Java, but first you need to define an interface that will work with stacks. So just declare an interface that works with this generic type T and allows you to pop, push, perform maybe some top on that stack and so on. So the basic operation for a stack data structure. And then you'll need to implement this generic stack within a class that again is generic, because at this point, at this lab or on this assignment A2, you need to work just with an execution stack that is filled with statements, so with objects of type I statement. But at some point, you may it may be required to work with some execution stack that works with procedures or functions that are called. So in that execution stack for a stack for procedures or function calls, and in that way, the item that or the element that will be used will be a procedure or a function that will be placed on that stack. So that's why you need to work with generics starting from the beginning, because these data structures will be adapted to the particular requirement for your interpreter. So please keep in mind that your let's say interface should be generic, and your implementation for for your stack should be generic as well. Now, in order to implement an actual stack, you can use a stack that is already defined in Java. Okay, and then this apply to stack what we have discussed until now. So all these aspects. Okay, but then you need to work with a symbol table that at some point may or at this point you need to work with symbol table that stores variables and values for those variables, but at other point you need to work with a map or a dictionary that stores other kind of data, like let's say like a heap memory, okay? And that heap memory is perceived as well as a dictionary or a map. And that's why you need again to work with a map or a dictionary that is generic. That's why it is told here that for the dictionary and the list that represents the out, you should work with generic structures as well. So you need to implement an abstract data type dictionary that is generic, that works with key and value, and for the list with element or type T. I think these aspects are somehow discussed later in this file. Okay, so please keep in mind that you don't have to work with this or you have to provide a solution for the next week. For the next week, let's focus on this part of the application. Let's try to implement these data structures, these generic data structures that allows us to process or implement our interpreter. Then for the next week, you may work with these elements, these program elements like types, statements, and so on. Or you may choose another way to work, but try to not feel overwhelmed by the amount of work, because you have several weeks at your disposal. Okay. Please let me know if you have questions until this point. Or because I have understood that you will work with generics during this week, you can start with these classes like statement, compound statement, and so on, because you already know how to define an interface and other simple elements. And then you may focus on generics next week after you discuss them during the seminar. Okay, so it's your choice. You don't have to follow a special working pattern on this assignment. Okay, let's go a little bit further and see other important element in your application, which is this class, program state, and that includes the execution state of your program. And your interpreter will work a lot with this class program state. And program state is defined by these three elements, which is the execution stack, the symbol table at this point, and the list that represents the output, what your interpreter should print on the, let's say, on the standard output. This program state consists at this point only of these three elements, and as well the original program. But later, during the following assignments, you will add some features that allows you to work with files, and all those data structures that allows you to work with files will be added here again. When you will work with heap memory or a procedure or a stack of calls, all these elements or data structures will be added here. So this is a simple, let's say, version of your program state, because as you will go over this semester, you will add elements in this class. You will add other attributes that will correspond to more complex, let's say, elements that your interpreter should work with. Okay, and when this program state is created, you need to provide the stack with statements, the symbol table, which initially is empty, and again on the output that will be used to print the results, together with the program. So the program, as some of you have seen, is hard-coded in your application. So you don't have to read it from the standard input. During last year or 2 years ago, I had a student that implemented everything from zero. So it's not the point to implement, let's say, a parser from the keyboard. In order to read your program. You just need to hard code your program and try to focus on the rules that your interpreter should follow. Okay, so don't try to, you can do it, but it's not the purpose of this lab activity. Only if you are, let's say, passionate enough and you have the corresponding amount of time to do that. Otherwise, you need to implement only what's required in every lab assignment. Okay, because otherwise it will be a lot of work to do for you. Okay, please let me know if you have any questions until this point.
So we don't have to write a parser. We only have to focus on the implementation of the
interpreter. Yes.
Okay.
Yes. So you will see shortly here. I think yes, here is the almost end of our discussion. Let's see now, because it's easier. Here is how your program should be printed, but you in your application you have to write down this line. So your program, you will be hard-coded in your application. You don't have to write a parser that will take this string and should parse it in order to build this program. Okay, you just hard-code in your program, in your application, this program. Okay, and here you have another example. Here we have several variables, several expressions that need to be assessed, and a value to be printed. And this part of code should be present in your application as well. And here is another example with the corresponding implementation. I think here is I statement. Okay, so if you are so passionate about programming, and you have time, you should write a parser. But otherwise, if you don't have time, or let's say you are not so passionate about programming, but I think you still are, you are not required to implement that parser. Okay, so let's go a little bit further and try to discuss about these data structures that you'll need to use. Now, we have seen that this program state consists of these data structures, okay? And here are some details related on that part that we have discussed here. Here we have the stack, we have the dictionary, and here we have the list that corresponds to the output. Okay, and for these elements we have, let's put it with a red star. Here are the details on your declaration of your generic types. Okay, so your dictionary or the interface My Dictionary should have key and value. My iList or the output should refer to a type, generic type T. Here is presented T4, but is T. Here we have a key and value, and so on. Here for let's see, for iStack, here we have a statement, and here you have some examples for your first, let's say, program state. You need to create a stack. We need to an execution stack. We need to create a symbol table and an output list, and to provide all these elements to our program state when it gets created. Okay. So here are those details. Now, all that we have discussed until this point refers to the model layer in your application architecture. And we can go further to discuss other layers. So until now we had the model. I write here again, we have statements, we have expressions, we have types, we have values. We have these data structures, let's say utils or something else. You can provide other name for that package that will consist of my iStack and so on. Okay, those interfaces and classes, my iDictionary and so on. Okay, and here at the repository level we have other classes. So let's see. Here the repository, it says it should consist of some list of program state objects. at this point in your application, it is not obvious why we should need such a list from for a program state. But because at some point we will work with threads, we need to add such a list. So within your repository, you will need to have other methods. Among them, you will need to add this method program state that will have you will need to add this method get current program. And here you will need to have a list L of let's say array list of program state. Okay, for example, and here you have this method get program state, get current program state, sorry, get current. Get current program state. Okay, and many other methods. Here, because we have a list of program states, maybe it will be useful to have a method add program state or remove program state, and so on. Add, remove, and so on. Okay. As I have said, at this point, maybe is not obvious why we should use that. Okay, let's go and discuss about the controller, because the controller is another layer in our application. And at that layer, we have, let's see, we need to have a reference to our repository. Okay, so we need to have a reference to our repository. And we need to add several methods, and those methods are described here. We need to have a method, it's not specified the visibility level for this method, one step, but let's place it here as a public method. One step, you have a small implementation for that method. Okay, here's the implementation, and you'll have another method, all step, that will execute one step at each time. And here you can see that the previous method that is defined here is implemented. So the status of execution stack until we have until our execution stack is not empty, we should perform one step at the time. Okay, and when the execution stack is empty, we should stop our execution. So at this point in our controller class, we need to have all step method as well. Okay, let's go a little bit further. Here we have another method to display the current state. Now this is an important aspect for us because we would like to see after each step what's the status of our program state, which means to check the contents of our execution stack, our dictionary, and our symbol table and our output list. And that's why we need such a method. So this method will be added here. So print program state. Okay, and that method will try to print the execution stack, status stack, exe stack, the sim table, and the output. Now, This is, as I have said earlier, this is the initial part, because later we will add the heap, we'll add the file table, and so on. Okay, so at this point, you just place the status of these elements, but later you will add other important aspects of your interpreter. Okay, let's see other elements that we have. We have another layer, the view layer. Here, let's say during the first assignments on our interpreter, the view part is, let's say, that is important, but because we are focused on the implementation of those rules, we intend to hardcode those programs, and we may have, let's say, a menu that will present our program 1, program 2, and so on, and the user may choose one of them, let's say 1, 2, 3, and so on. And according to the user's choice, the controller will allow us to execute that specific program, and the specific program will be actually hard-coded. So again, it is somehow easier for us to work with the view part. Okay, and each time we want to run a different program, we need to work with a different program state, or an initialized program state that has an execution stack that is formed out of that program that was chosen. Then the symbol table is empty, and the output again is empty. So each time we switch our program to be executed, we need to initialize our interpreter, let's say. Okay, so this would be your assignment for the next week. Here we need to work on other aspects like exceptions, and here you have several cases where you need to add your special cases, or what kind of special cases you need to handle. Okay, in your dictionary. Okay, your stack, your output list, you need to handle division by 0 when you assess expressions, and when your execution stack is empty at this point. Let's see here. When your execution stack is empty, you need to throw an exception that will print a message. The execution stack is empty, or something like else, something like this. Okay. Please let me know if you have any questions. I would like to say that maybe you may feel overwhelmed by all the classes or the data types, generics, layers in your application, but try to get them easily, each step at a time. First, because you haven't talked about the generics, you may want to implement the first part of the model layer, which is working with statements, compound statements, and so on. It's easier to start in this way. Okay. Please let me know if you have other questions. Okay. If you don't have other questions, I think we can stop here. I think there was one of your colleagues that didn't turn in his assignment. If you have finished, Raul Bajmatara, are you still here with us? If you haven't finished your homework, you can turn it in next week. But it's your choice. Okay. Other questions related to this assignment?
If we have questions while doing our assignments, like during these 3 weeks, can we contact you on Teams or on email?
Yes, you may write. You may write on this channel that we have there, because I think it's your choice here again. If you ask me in private, you can ask me in private on Teams, or I prefer Teams instead of email. Okay, because it's quicker for me to answer and for you to ask your question. And if you want, you may use the channel that we have here. Let's see it. This channel, okay? But it's your choice, because it may be the case where your question is another question that another colleague of yours might have. Okay, so it's easier for me to answer to multiple questions that address the same issue.
Yep, it's fine.
Okay. Other questions? Okay, so I think we can stop here. Start to work on this assignment with the simple or the less complex part. And next week we'll resume, and we may continue our discussion, because I think next week you'll have other questions, because you have already started to work on this assignment. Okay, thank you for attending the lab.